All right, in this video, we're going to talk about section 3-2, which is addition of whole numbers. And in this video, we'll recognize number relationships, including comparing and ordering. Also, we'll recognize the meaning of addition by studying various models. Also, we'll use properties of addition. We'll use addition algorithms, including the standard algorithm, to solve problems. Also, we'll calculate numbers using bases other than 10. And use mental addition computational skills and estimation. Okay, we'll start off with addition models. We'll look at some models of how we can add whole numbers. One of them, of course, is the set model. Now, the set model is one way to represent addition of whole numbers. Like, suppose Jane has 4 blocks in one pile and 3 in another. If she combines the two groups, how many objects are there in the combined group? Okay, so here we have one model where there are 4 blocks here, and another model for set B, which is, of course, 3 blocks. So here the number of blocks in A is 4, the number of blocks in set B is 3. If you combine the two groups, you'll see that the total number of blocks in that combined group will be 7. So that means a number in set A plus a number in set B, that will be 4 plus 3, which is 7. And that represents the number of objects in A union B. And note that the sets must be disjoint. In other words, they have no elements in common, or an incorrect conclusion can be drawn. Okay. So here's a formal definition of addition of whole numbers. If we let A and B be 2 disjoint finite sets, and disjoint means that what's in A is not in B, and what's in B is not in A. Those two sets have nothing in common. So if the number of elements of A is equal to lowercase a, and the number of elements in B is equal to lowercase b, then A plus B will be equal to the number of elements in the union of sets A and B. Now, the numbers A and B are what we call add-ins. A plus B, whatever we get for A plus B, that will be the sum. So in this case here, the 4 and the 3 are your add-ins. When you add 4 and 3 together, you'll get 7. That 7 represents the sum. So in this first example, for which of the following is it true that the number of elements in A plus the number of elements in B is going to be equal to the number of the elements in the union of A and B? Okay. So in part A, we got A, which has the elements A, B, and C, and B with the elements D and E. Now notice that in set A and set B, there are no elements in common. Okay, so this would be true for part A. Because A and B in this case are disjoint sets. Now, what about part B? We got A with the elements A, B, and C, and B with the elements C and E. In this case, if you look at A and B, there is one element that's in both A and B, and that's element C. So this rule would not be true for this situation because there's something in common for sets A and B. And that's element C. And part C, A with the elements A, B, and C, and B is the empty set. Well, there's no elements in the empty set, if you recall. But A does have A, B, and C. So there is nothing disjoint about A and B. So this rule would be true for this set, for this problem, I should say. Okay. All right, the next model is the number line model. Okay, we can use that to add whole numbers. Here's a couple of situations here. Kenzo has 4 feet of red ribbon and 3 feet of white ribbon. How many feet of ribbon does he have altogether? And a second situation would be something like this. One day, Laura drank 4 ounces of orange juice in the morning and 3 ounces at lunchtime. If she drank no other orange juice that day, how many ounces of orange juice did she drink for the entire day? Okay, so in this case here, students do need to understand that the sum represented by any 2 directed arrows can be found by placing the endpoint of the first directed arrow at 0 and then joining to it the directed arrow for the second number with no gaps or overlaps. So in this case, if we were to, we know we got to add 4 and 3 in both of these situations here. So you start at 0 and go to the right 4 places. And then we want to add 3 more to that. So from there, we add 3 more by going to the right 3 again. And we end up at, as you can see, 7. From 0 to 7, that represents 4 plus 3. Okay. All right, so now for homework example number 2. And by the way, these are examples that are similar to what will be in the homework. If we want to add using a number line, that we can do, like 9 plus 3. So for that, we started 0. For the 9, to represent 9 on the number line, we go to the right 9 places. And then, let's say I want to add 3 more to that. So starting at 9, we go over 1, 2, 3 places. So here we're going to end up at 12. So that means that 9 plus 3, I'll represent that in another color. That's from 0 all the way to 12, because that's going to be 9 plus 3. And of course, 9 plus 3 would give us 12. So that's how we add using the number line. All right, next we'll look at how to order whole numbers. A horizontal number line can be used to describe greater than and less than relations on the set of whole numbers. So now we can define what less than means. For any whole numbers A and B, A is less than B, which is written like this. And that symbol is the less than symbol. A is less than B if and only if there exists a natural number called K, such that A plus K is going to be equal to B. So if you think of that, when we got 9 plus 3 is equal to 12, we can say here that 9 is, of course, less than 12, because I can find some number K or some natural number K where, in this case, 9 plus whatever that whole number is would be equal to 12. Now, for A is less than or equal to B, that's the notation for less than or equal to. What that means here is this: A is less than B or A is equal to B. And for A is greater than B, this is a symbol for greater than. This also is saying that B is less than A. So if I say here, let's say 15 is greater than 7, if I switch this around, then to make that true, I have to put less than. So 15 being greater than 7 is saying the same. 7 is less than 15. All right, sometimes equalities combined with a greater than and less than inequalities to give the relations greater than or equal to or less than or equal to denote, and that's denoted by these symbols. That's greater than or equal to and less than or equal to. Usually they will have the line underneath that inequality symbol to say that it's going to be either greater than or equal to or less than or equal to. So thus A is less than or equal to B means A is less than B or A is equal to B. All right, now let's look at how we can master basic addition facts. Okay. And these are just some strategies for mastering basic addition facts. One of them is the counting on approach. And that strategy of counting on is where addition is performed by counting on from one of the numbers. Like, for example, 5 plus 3. We can compute by starting at 5 and then counting to 6, then 7, then 8. So 5 plus 3 would be equal to 8. And the addition of 7 plus 4, we can start with 7 and then count to 8, 9, 10, 11. Okay, so those are just a couple of illustrations of the counting on approach. Another strategy would be the use of doubles, such as 3 plus 3. That receives special attention. And after students master doubles, then doubles plus 1 and doubles plus 2 can be learned easily. Like if a student knows what 6 plus 6 is, which is of course 12, then using the associative property of 6 plus 7 plus 6, we can break that up as 6 plus 1, 6 plus 1, or group that as 6 plus 6, which is of course 12, and then one more will make that 13. So that's the doubles approach. And then making 10. Another strategy of making 10 would be adding any remaining, making the 10 and then adding the remaining, okay? And one way is to use 10 frames to make a 10. Like on the next page of this handout, you're gonna see a strategy for making 10. So if we want to add 7 plus 4, in this case, we'll make 10 to add that. So that means, in this case here, we'll take these 3 counters, move them over. So now you have 10, and then you got 1 left over. So 10 plus 1 would be 11, which is going to tell us what 7 plus 4 is. That is 11. Okay. I'm going to bring this down a bit because there's a couple of guided practice examples here. Like 7 plus 6. So here you want to draw counters to make 10 and then write their sum. All right, so we can make 10 by moving 3 of those counters over, as you can see here. And then that means you'll have 3 left over. So we know 10 plus 3 will have to be 13, which means 7 plus 6 will be 13. And then in problem number 2, 8 plus 6 is how much? Well, we got 8. If we want to make 10, let's add 2 counters here to make 10. And that means we're going to have 1, 2, 3, 4 left over. So that means the 10 plus the 4 left over will give us 14. So that means 8 plus 6 will give us 14. Okay. So that's just a strategy of making 10. All right, next is whole number addition properties. And you're going to be seeing these properties again when we go into multiplication. Also, we're going to be dealing with things like integer addition, also addition with rational numbers. You'll see this come up from time to time throughout this course, and also maybe in Math for Teachers 2, which is also a required course as well. All right, so we start with the closure property of addition of whole numbers. And that's this. If A and B are whole numbers, then A plus B would give us a whole number as a sum. So what the closure property implies that the sum of two whole numbers exists and that the sum is going to be a unique whole number. So for 5 plus 2, we're going to end up with a unique whole number, which is in this case 7. Okay. Let's say we have this example here. Which of the following sets are closed under addition? And if the set is not closed under addition, explain why. So let's say we have something like this. In part A, we got B, set B with the element 0. I want to determine if that's closed under addition. And what that means here is this. If I take the sum of any two numbers, that sum has to be in that set. So like we only have 0. Well, 0 plus 0 is 0. And 0 is in that set. So this is true. And then for part B, the set of all t is going to be equal to the set of all 3 times x, such that x is a element of the whole numbers. Okay. Now in this case, if I write it a different way, 3x and x is a whole number. That means whole numbers start with 0, and then 3 times 0 is 0. Then 1, 3 times 1 would be 3. For 2, 3 times 2, which is 6, then 9, and so on. That would be closed under addition, because if I take 3 and 6 and add that together, I would get 9, and 9 is in that set. Also, 9 plus 6 will be 15. Since this is an infinite set, that means 15 is included in that set, because 15 is a multiple of 3. So this will be true as well. And then part C, the set of n equaling to 1, 2, 3, 4, 5, and so on. Well, that too is closed under addition. I can add 5 and 4 together. That would give us 9. And if I take this out, 9 would be in this set, in this infinite set. This too is also true, that it is closed under addition. Now let's take a look at part D. D has the elements 4, 6, and 8. Well, if I add 4 and 6 together, I would get 10. Is 10 included in this set? It's not. So that means I have to say false, okay? Because it's okay, because I can add, and this is just an example. I can add 4 plus 8, and that's 12. But that is not an element in V. It's not in V, in set B. So that's why it's not closed. Now, what about part E? X, such that the X is an element of the whole numbers and X is greater than 18. If I was to write that a different way, greater than 18 means if it's a whole number, it has to start with 19, then 20, 21, 22, and so on. I can add any of these two numbers and that sum will still be in this set because of the ellipsis saying that it's an infinite set. So this will be true, that it is closed under addition. Now, what about 0 and 1? Notice if I add 1 plus 1, I'm going to get 2. 2 is not in this set, so this will be false. And one reason would be like 1 plus 1 is not in the set. Okay, so that's the closure property. All right, next we'll look at the commutative property of addition of whole numbers. The commutative property of addition of whole numbers. Now, if A and B are any whole numbers, then the sum of A plus B is going to be equal to the sum of B plus A. Now, what that means is this, that the order does not matter. The order when you add the two numbers does not matter. So here we can just say order of adding two whole numbers does not matter, because you're going to end up in the same sum. Like with the 3 plus 5, you'll get the same answer as if you were adding 5 plus 3. And then next is the associative property of addition of whole numbers, where if A, B, and C are any whole numbers, then if I add A plus B first and then add C to it, I'm going to get the same answer as if I added B plus C first and then add A to that sum. So in other words, this deals with grouping. Okay. So grouping does not change the answer. Does not change the answer. So in other words, if I did 24 plus 8 plus 2, I can group the 24 and the 8 together like this. And 8 plus 8 will give you 32, and then 32 plus 2 will be 34. Or I can do this, group the 8 and the 2 together like this right here, and do 8 plus 2 first, which is 10. 10 plus 24 will give me 34. I still get the same sum. So the grouping does not change the sum. All right, and also we have the identity property of addition of whole numbers, meaning that there is a unique whole number called 0, which is what we call the additive identity, such that for any whole number A plus 0 will be equal to A, and also 0 plus A will also give us A as well. Okay. So let's say in this example here, which properties of whole numbers are illustrated in the following statements? So in part A, we got 5 plus 7 is equal to 7 plus 5. Well, notice that the order of the two numbers are different, but I'm still going to get the same sum. So this represents the commutative property of addition. And we have to say what it is exactly. We just can't say commutative property. We have to say commutative property of that operation, which is in this case, commutative property of addition. And then part B is 1001 plus 733 is a unique whole number. So here, if we add two numbers, we're going to get a unique whole number, which is in this case, the closure property of addition. The closure property of addition. Now in part C, we got 3 plus 5 in parentheses plus 7 is equal to 5 plus 3 in parentheses, and then plus 7. Now you want to be very careful here because you might see the parentheses and think that this would be the associative property, but that's not always the case because you have to look at what's inside the parentheses, what's going on there. 3 plus 5 and then 5 plus 3. Notice that the order has changed. And when the order changes and you still get the same sum, that would be the commutative property of addition. And then finally, 8 plus 5 in parentheses plus 2 is equal to 2 plus in parentheses 8 plus 5, and then that's equal to 2 plus 8 in parentheses plus 5. This situation has two different properties going on. Notice that the grouping, notice that the order has changed here. 8 plus 5 is first, and then the 8 plus 5 is second on this side. The order has changed. So there is a commutative property going on. And then from here to here, the grouping of the 2 and the 8 is different from the 8 plus 5. So there are two properties going on. One is the commutative property, and I'll just say commutative, and associative properties of addition. Okay. All right, now here's another homework problem. Let's say I want to fill in the blank. You got 5 plus in parentheses 8 plus 7, and that's equal to, and on the right side of the equal sign is 8 plus 7 plus what number? So here you just want to fill in the blank here. So we got the 8 plus 7 here. What's missing there is the 5. So we just fill in that number. And then we're going to identify the property based on this. Notice the 8 plus 7 is still in the parentheses on both sides. We got the 5 here and the 5 here. The order has changed. So with that, it is the commutative property of addition. Okay. All right. The next homework example is this. We want to state the name of the property illustrated here. We got 8 plus, and then in the bracket 2 plus 4, and then that's equal to 8 plus, and in the bracket 4 plus 2. Notice here, the 2 plus 4 and then 4 plus 2, the order has changed on these numbers. So that means we have the, again, the commutative property of addition. And then next, we're going to find the solution of 3 plus 0 is equal to x. And by looking at this, you can see that this is the identity property, meaning that we have the unique whole number 0, where some number plus 0 will give you that number back. So 3 plus 0 has to give you 3. And that's all there is to it. Okay. All right, now next we're going to look at some algorithms here. All right, one of the algorithms is a concrete model right here. As you can see here, we have one flat, which represents 10, one long representing 10, and 1, 2, 3, 4 unit blocks. That represents the number 14. And 23, we have 2 longs and 3 flats. 3 unit cubes. If we combine those, this is what we have. 3 longs, 7 unit cubes. And that represents the number 37, because 1 long represents 10. 10 plus 10 plus 10, that's 30, and 7 will give you 37. So 14 plus 23 is 37. That's just using the concrete model using base 10 blocks. And then we got the expanded algorithm for 14 plus 23. So here we add the 1. So 4 plus 3, that's 7. And then add the 10s. This is actually 10 plus 20, that would give you 30. And then add those partial sums. 7 plus 30 will give me 37. So 14 plus 23 will be 37. And of course, you have your traditional standard algorithm where you just add the 1's digits, 4 plus 3, that's 7, and add the 10's digits, 2 plus 1 will be 3. 14 plus 23 is 37. Okay. And then we have the expanded algorithm with what they call regrouping. And what that means here is this. If I add 7 and 8 together, adding the 1's place, that would give me the 15, as you see here. And then if we add 30 and 20 together, those are your 10's, that would give you 50. And if I add those partial sums, 15 plus 50 would give me 65. But the traditional standard algorithm tells us to do this. 7 and 8 is 15. We write down the 5 and regroup the 1. That's why you see that 1 on top. So here, 3 plus 2 is the 5, plus this 1 will be 6. So 37 plus 28 will be 65. So you add the 1's, regroup, and add the 10's. Okay. Now, here's the partial sums algorithm. Partial sums algorithm. And the partial sums algorithm for addition, one computes all the partial sums, working one place value at a time, and then add all the partial sums to find the total sum. Place value columns can be added in any order, but working from left to right, that is, from the greatest place value to the smallest place value, would be best. So like in this case here, if we have 568 plus 757, we start with the greatest place value from left to right. 5 plus 7, the 5 and the 7 are in the hundreds place. 500 and 700 will give you 1200. And then the 6 and the 5 are in the tens place. That's 60 plus 50, that's 110. And then the 7 and the 8 are in the ones place. 7 plus 8 would be 15. These are your partial sums. If you add those partial sums together, you'll end up with 1,325 as the final answer. Okay. All right, next is the lattice method, or the lattice algorithm for addition. This one I personally like the best. To use a lattice algorithm, we add the single digit numbers by place value on top of the single digit numbers on the bottom and record their results in a lattice, and then add the sums along the diagonals. Like for 3,567 plus 5,678. Here's what we do. We're adding a 4-digit number to another 4-digit number, so we need 4 boxes. Each box will be separated by diagonals, as you can see here. And then we add along each place value, like 7 and 8, that would be 15. We put each digit in one of the triangles. So if 7 and 8 is 15, the 1 has to go in the top triangle, the 5 must go in the bottom triangle. 6 and 7 would be 13. So the 1 goes in the top triangle, the 3 goes in the bottom triangle. And then 5 and 6 will be 11. The 1 goes in the top triangle, the 1 goes in the bottom triangle. 3 plus 5 is 8. It's a single digit sum. So the 0 goes in the top triangle and the 8 goes in the bottom triangle. And now to find out what that final sum would be, we add along the diagonals here. So we have nothing to add to the 5, so we bring that down. Add 1 and 3 together, you'll get 4. Add 1 and 1 together, you'll get 2. 8 and 1 together will be added to get 9. So that means 3567 plus 5678 will be 9,245 as the final answer. Okay. So now let's use that lattice algorithm on these homework problems. Like in part A, we got 3,557 plus 3,994. And here I'm adding a 4-digit number to a 4-digit number, so I know I'm going to need 4 boxes here. Each box will be separated by a diagonal, like this. And then we add those sums at each column, one at a time, like 7 plus 4, that's 11. That means the 1 goes here and the 1 goes here. And then 5 plus 9 will be 14. So 1 goes here and the 4 goes down here. 9 plus 3 will be 12. So the 1 goes here and the 2 goes here. 3 plus 3 is 6. It's a single digit number, so I need a 0 on top and the 6 on the bottom. And then next I add that sum along the diagonals here to come up with my sum. Like I have nothing to add to the 1, so I bring that down. Here, 1 plus 4 will be 5. Along this diagonal, 1 plus 2 will be 3. And along this diagonal, 1 plus 6 will be 7. I'm not going to worry about the 0 there because I have nothing to add to it. So 3,557 plus 3,994 would be 7,351 as the final answer. Okay. Part B, 5,723 5,723 plus 9,788. Again, a 4-digit number is being added to a 4-digit number. So I need 4 boxes. Each box will have a diagonal going across like this. That's how we set this up. And then we add column by column by place value. 3 plus 8 will be 11. So 1 goes here and the 1 goes here. 2 plus 8 is 10. So the 1 goes in the first triangle, 0 goes in the second triangle. 7 plus 7 is 14. So the 1 goes here and the 4 goes down here. 5 plus 9 is 14. So the 1 goes up here and the 4 goes down here. And then we add along these diagonals here that I'm drawing. I have nothing to add to this 1, so I put that down. 1 plus 0 is 1. 1 plus 4 is 5. 1 plus 4 again, that's 5. And I have nothing to add to the 1, so I bring down the 1. So 5,723 plus 9,788 would end up being 15,511. And that will be the final answer there. Now that's how we use the lattice method or the lattice algorithm to add two numbers. And this is real good for students who are not real good at doing large numbers of math. But the fact is you have to know what your basic addition facts are in order to do this. All right, next we'll look at column addition, the column addition algorithm. The column addition algorithm. So in the column addition algorithm, we add the numbers in each column, writing each sum directly beneath the column. Then we regroup each place one column at a time. Base 10 blocks are often used in the column addition algorithm, as illustrated on the next page. So in this case here, if I wanted to solve 144 plus 37 using the column addition and base 10 blocks. Okay, so the first step, we represent the amounts 144 and 37. So 144 is going to be 1 flat, 4 longs, 3 unit cubes. 37 is going to be 3 longs and 7 unit pieces. And then the next thing we do here is sets going to be combined if any column has 10 or more objects. And those 10 objects will be exchanged for one of the objects to the immediate left. Now, in this case here, we have 11 unit pieces here. So I can group 10 of these and exchange it for 1 long. And that's because 1 long is equivalent to 10 unit pieces. Okay. And that means we'll be left with 1 unit piece here. And here we have 1 flat. This time you'll have 8 longs in 1 unit piece. And that represents 181. So 144 plus 37 will be equal to 181. Now that's using base 10 blocks. Okay. But let's just say we had bigger numbers like 568 plus 357. And we want to use the column addition algorithm. Sometimes base 10 blocks would not be sufficient to do this. So here's what we have. For the hundreds, tens, and ones, we put each digit in its proper place value position. So the 5 is in the hundreds place, 6 is in the tens place, and 8 is in the ones place. The same with 357. 3 is in the hundreds place, 5 is in the tens place, 7 is in the ones place. And then you're going to add the numbers in each column, like 8 plus 7, that's 15. 6 plus 5 is 11, 5 plus 3 will be 8. And then you're going to regroup the 10 ones to the tens column. In this case here, I'm going to regroup by subtracting 10 in the ones column. And then since 10 ones make up a 10, I can add that 1 to the 11 to get 12. So I'll be left with 5 ones and now 12 tens. And then next, I got 12 tens. Well, 100 makes up 10 tens. So we'll take 10 from that, and that'll leave us with 2, and then add 1 to the 8 to get 9. So 568 plus 357 will give me an answer of 925. That's just using the column additions algorithm or another method. All right, next we'll look at the opposite change algorithm. Here's another method for adding whole numbers. In the opposite change algorithm for addition, we decide which add-in is closer to a nicer number. Typically, it'll be a 10 or a multiple of 10, and then decide how to adjust that add-in so that it ends in one or more zeros and adjust the other add-in the opposite way. And the goal is to make the addition problem a problem without the need to regroup. Like if I want to add 189 to 278 using the opposite change algorithm, this is what I'll do here. I know 189 is 1 less than 90. So let's add 1 to the 189 and subtract 1 from the 278. Add 1 to the 189, you'll get 190. Subtract 1 from the 278, you'll get 277. But let's make 190 200 by adding 10 to it. So if I add 10 here, the other add-in, I need to subtract 10. So 190 added to 10, you'll get 200. Subtract 10 from 277, you'll get 267. So we got 200 plus 267, which we can easily add and come up with the answer of 467. Okay. So here we have an easier problem that we can do without having to do any regrouping. So that's the opposite change algorithm. And then we got the scratch algorithm for addition. Let's say we have 87, 65, and 49. We're going to add those three numbers together. All right, first of all, you add the numbers in the units place starting at the top. When the sum is 10 or more, you're going to record that sum by scratching a line through the last digit, add it, and writing the number of units next to the scratch digit, like in the ones digit, 7 plus 5, that's 12. We scratch out the 5 and we wrote down the last digit in the sum of 12, which is, of course, 2. And then we add 2 plus 9, that would give us 11. We scratch the 9 out and write down the number that's in that last digit, which is the 1. So here we're going to continue adding the units, including any new digits written down when the addition, again, results in a sum of 10 or more, and then we repeat the process. Okay. Now, when the first column of additions is completed, we write the number of units, which is the 1, below the line, as you can see here. And then we count the number of scratches. Here we have 2 scratches, so that 2 goes up here at the top, and then add that number to the second column. And repeat that procedure for each successive column until the last column with non-zero values. And then at this stage, sum the scratches and place a number to the left of the current value. So in this case here, 2 plus 8, of course, that's going to be 10. So we write down a 0 here and scratch out the 8. And then add 0 and 6 together, that would be 6. And then 6 and 4 would be 10. So we write down the last digit in 10, which is 0. Okay. Now we got 2 scratches here, so we bring over the 2, and that 2 would go in front. So that would be 201. So 87 plus 65 plus 49 would be equal to 201. Okay. That's how we use the scratch algorithm for adding 2 or more numbers in this case. All right. Now let's look at some mental math techniques and estimation for whole numbers. Mental mathematics is the process of producing an answer to a computation without using computational aids, that is, without using a calculator or software or whatever. Computational estimation is the process of forming an appropriate answer to a numerical problem. Okay, so let's start off with some mental mathematics techniques for addition. And here I got 5 of them right here on this handout. One of them is adding from the left, like 76 plus 25. So here we take the digits in the tens place, which is 7 and 6, that represents 70 and 20. Add those together, that give you 90. And then add the 1, 6 and 5, that would give you 11. And add these two sums. 90 plus 11 would be 101. And then breaking up and bridging is another mental math technique for addition. Let's say I take those same numbers, 76 and 25. Here we add the first number in the tens and the second number, 76 plus 20. We take the first number and the tens of the second number, 76 plus 20, that's 96. And then add the sum of the units in the second number, the 5. 96 plus 5 will be 101. And then next is the trading off approach. Okay. The trading off is this. We add some number to make it a multiple of 10 and then subtract that same number from the second to compensate. Like 76 and 25, 76 is 4 away from 80. So if I add 4 to the 76, I'll get 80, which is a multiple of 10. But since I added 4 to the 76, I need to subtract 4 from the 25 to compensate. So 4 from 25 will give me 21. And then we can add 80 and 21 together to get 101. And then next is using compatible numbers. Here, compatible numbers are going to be numbers whose sums are easy to calculate mentally. Like if we have 130 plus 50 plus 70 plus 20 plus 50. Compatible numbers will be something like 130 and 70. If I add 130 and 70 together, you'll get 200. And then 50 and 50, of course, if I add 50 and 50 together, that's 100. And I got 20 left. So 200 plus another 100 is 300, plus 20 will be 320. So that's how we use compatible numbers to add. And then next is making compatible numbers. This is procedure number 5. Well, for 76 and 25, well, a compatible number with 25 would be 75. So if I add 75 and 25 together, I'll have 100. But then 75 is 1 less than 76. So let's add the 1 to that 100. That would give you 101. Okay, so that's how we use compatible numbers here to add whole numbers. All right, and some of these mental math techniques will be used in these examples. Like, let's say we want to use breaking up and bridging to compute each of the following, like 281 plus 75. $281 plus 75. So if I want to use that breaking up and bridging approach, this is what I'll do. Take the 281, add to it the tens value of the second number. The 7 is in the tens place, so I'll break that up as 70. So 281 plus 70 would give me 351. And then I got 5 more to add. So the 351 plus the 5 would be 356. So 281 plus 75 would end up being 356. So yeah, just break up the 75. It's like 70 plus 5. Add 281 to the 70, that'd be 351. Add the 351 to the 5, you'll get 356. And in part B, we got 334 plus 246 using the breaking up and bridging method. Well, let's take that 334. The first number is a 2 is in the hundreds place, so we'll add 200. That would give us 534. And then take that 534, add that to the 4, which is in the tens place. So 534 plus 40 would be 574. and then take the 574, add that to the 6, which is in the ones place. That would give us 580. So 334 plus 246 would give us 580 as the final answer. All right, now in this next example, let's say I want to use a trading off approach to compute each of these mentally. So let's start with 47 plus 25. 47 plus 25. Well, let's make 47 a multiple of 10. Well, 50 is 3 more than 47. So if I add 3 to the 47, I'll get 50. But if I'm going to add 3, I need to compensate for that by subtracting 3 from the 25. That would give us 22. So 50 plus 22 would give us 72, which is what 47 plus 25 would be equal to, 72. And then in part B, we got 79 plus 56. Well, notice that 79 is 1 less than 80. So let's make that 80 by adding 1 to it. So 79 plus 1 is 80. But if I'm going to add 1 to the 80, I need to subtract 1 from the 56 in order to compensate for that, for what I did. So 56 minus 1 would be 55, actually. So 55 from 80, of course, would be, let's say, 25. So 79 plus 56 will be, hold on. If we're adding these two, not subtracting. 55 plus 80. Well, 8 plus 5, that's 13. And then bring down the 5. So 79 plus 56 will be 135. Okay. So that's how we use the trading off approach to add two numbers. Okay. Now let's talk about computational estimation. And here there are, in this case, a few of these that we can look at. One would be the front end with adjustment. And the other one is computing with nice numbers. And actually there are 5 that we'll look at. So starting with front end with adjustment, let's say we had 474, 522, and 231. We want to add those numbers together. The way we use the front end with adjustment approach is to add the front end digits, like 4, 5, and 2. That would be 11. And the place value for those is in the hundreds place. So that means this would be 1100. And then adjust, like 22 and 31, that's approximately 50. And then 74 is going to be approximately 70. So 50 plus 70 will be 120. And then the adjusted estimate would be the sum of 1100 and 120, which would give you approximately 1220. So that's how we use the front end with adjustment approach. And here's a couple of examples of just that. Let's say we got 6,443. 2001, 4,056, and 998. And here I want to use a front end estimation with adjustment to come up with my answer for this. Okay, so let's look at the front end estimation here. Just add the front end numbers, 6, 4, and 2. So in this case, it's 6 plus 2 plus 4. 6 plus 2 is 8 plus 4 is 12. And these digits are in the thousands place. So we know we got 1,200 for that place value. And then we do some adjusting here. Well, let's look at the 443 and 1. If I estimate that, that would be something like 400. And I need to apologize for that. That 12, this should not be 1,200. This should be 12,000, because actually these are in the thousands place, so that would be 12,000. And then plus 400, which is actually in the thousands place. I mean hundreds place as well. Plus that 998 is close to 1,000. So let's add that as well. Okay. And then something else. Let's see, 43 and 1 and 56. If I add those, that's closest to 100. So I'm gonna add another 100 to that. So 12,000 plus 1,000 would be 13,000 plus 400 plus another 100 will end up being 13,500. So using front end with adjustment will be 13,500. So that's part A. Now part B, here we got 234, 179, 929, 118, 463. We're adding those together. Well, let's look at the numbers that are in the hundreds place. Those front end numbers, the 2, the 1, the 9, the 1, and the 4. If I add 2 plus 1, that's 3, plus 9 is 12, plus 1 is 13, plus 4 is 17. And these are in the hundreds place, so 1,700 would be part of that. And that comes from the place value. Now, let's look at these numbers here on the right here, like 34 and 79. That's close to 100. And then 29, 18, and 63. Well, no, that's 47, 63. That's also close to 100. And that would be approximately 1,900. Okay. Now, I'm not sure how precise that they want this front end estimate. Okay. But 1,900 would be a good estimate for this. All right. Next is talking about grouping to nice numbers. That's the second approach. So if we had 23, 39, 32, 64, and 49, and we're going to add those 5 numbers together, here we group to nice numbers. Like if we group 30, 23, 32, and 49, that sum would be about 100. And also 39 and 64 would be approximately 100. So 100 plus another 100 would be 200. All right, and next is the clustering method. This is number 3 in mental math in estimating. And that's used when a group of numbers cluster around a common value. Like for these numbers here, as you can see, these 5 numbers cluster around about 5,000. Because you got 3 numbers that are above 5,000, only 2 numbers that are real close to 5,000. So if I take the average, in quote, of 5,000 multiplied by the 5 numbers that I have here, I got 25,000. So the sum of these 5 numbers would be approximately 25,000. And then we got rounding as another way of estimation. And in this case here, 7,262 minus 3,806. Let's say to the nearest thousand. We want to estimate to the nearest thousand. We look at the number in the thousands place, which is a 7. The number to the right of it is a 2. If that number to the right of the number that you're trying to round off is less than 5, we leave that number in front as is and then convert the numbers behind it to 0. Here, the 2 is less than 5, so the 7 remains the same. The 2, the 6, and the 2 will change to zeros. Now for 3,806, to the nearest thousand, we look at the 3, which is in the thousands place. Then to the right of it is 8. Here, 8 is 5 or greater. That means we increase the 3 to a 4 and change everything to the right of it to zeros. So 7,000 minus 4,000 would be approximately 3,000. That's the approximate difference here. Okay, now in this homework example, we're going to round to the nearest 100. You're just going to get some idea of rounding to the nearest place value position that's indicated. So here to the nearest 100 is what we're trying to round for 1,445. Well, we look at the digit that's in the hundreds place, that's a 4. The number to the right of that is another 4. Well, here 4 is less than 5, so this 4 is going to remain the same. So I'm going to have a 1, and then the 4, and then the numbers behind the digits that I'm trying to, behind the place value that I'm trying to round off to convert to 0. So 1,445 to the nearest 100 would be approximately 1,400. And then next we use the method of finding the range to estimate a sum. So let's say we had 7,262 plus 3,806. Okay, now we're looking at the first place value positions you have. And in this case, is the thousands place. So 7,262 is going to be between 2 numbers using a multiple of 10, in this case, a multiple of 1,000. The low end would be 7,000, but the high estimate, we add 1,000 to it to get 8,000. So 7,262 would be between 7,000 and 8,000. Similar note, 3,806. The low end of that would be 3,000. The high end of that would be 4,000. And then we add the sum of the low estimates and the sum of the high estimates to get the 2 numbers where the sum of these 2 would fall between. 7,000 and 3,000 would be 10,000. And then 8,000 plus 4,000 would be 12,000. So here, this sum will be between 10,000 and 12,000. Now keep in mind the range, you have to have a low estimate and a high estimate. You have to have 2 numbers. So let's say in this example here, I want to use the range strategy to estimate each of the following. Like 298 plus 439. $298 plus 439. Now, the 2 and the 4 are in the hundreds place. So we need to find a range in the hundreds place for 298. Well, the low end of 298 will have to be the 200. The high end of 298 will have to be 300. So 298 is between 200 and 300. So this is your low estimate, and this is your high estimate. And then for the 439, I do the same thing. The low end of 439 would be 400. The high end of 439 would be 500. And then I add those low and high estimates together. 200 and 400 would be 600. 300 and 500 would be 800. So that means that the sum of 298 and 439 would be between 600 and 800. It would be from 600 to 800. That's the range. I'll do the same thing for 408 added to 21. Well, 408, the low end of that would have to be 400. And of course, the high end, I'll add 100 to that, would be 500. And then for 21, the low end of that would be 20. And then the high end of that would have to be 30. Add your low estimate and add your high estimate, you'll get the range. 400 plus 20, that's 420. 500 plus 30, that's 530. So that means that the sum of 408 and 21 will be between 420 and 530. Okay. And finally, suppose you had a balance of $2,614 in your checking account, and you wrote checks for $76, $272, $404, and $529. Estimate the four check amounts and the beginning balance to the nearest hundred to estimate the new balance. Okay. So our balance was $2,614. And I want to estimate that to the nearest hundred. So the 6 is a digit in the hundreds place. To the right of it is 1. That's less than 5. So we're going to round this off to 2,600. And now my check amounts. I have $76, $272, $404, and $529. Now I'm going to estimate those four check amounts to the nearest hundred. All right. This may be hard. That's 76. I'm going to round this off to 100. 272 to the nearest hundred would be 300. 404 to the nearest hundred would be 400. And 529 to the nearest hundred would be 500. Now we're going to add these estimates together. 100 and 300, that's 400, plus another 400 is 800, plus another 500 would be 1,300. So my check, the sum of those four checks will be approximately 1,300. And now let's subtract 2,600 minus the 1,300, and you'll end up with $1,300. So the new balance will be estimated at $1,300. Okay. All right, so that does conclude this video on section 3.2 dealing with addition of whole numbers. And I know there's a lot that's covered in this particular section, and there is homework available in my math lab. So try your best to do those problems there, and feel free to contact me if you have any questions about anything that's presented in this video or any of the homework problems in my math lab.